Okay, this lab 12 part 2 is about IR proximity sensor, and we have to simulate the code for IR proximity sensor. This is the code for IR proximity sensor. According to this code, we have declared the liquid crystal.h file, and we have to declare this pin number 13, 12, 11, 10, 9, and 8. The pin number 13 is used for RS of the LED, and pin number 12 is used for enable of the LED, and 11 is used for D4 of the LED, and 10 number is for D5 of LED, and 9 number is used for D6 of LED, and 8 number is used for D7 of LED. And we have IR pin will be inserted into uh, analog analog port of A0, and this is the wired setup, and in which we have to initialize the variable which will run for the first time, and then it will for initialize purpose, then we have to run while loop when at the end of the uh, at the end of the 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 stop of this project. So we have to declare float volt analog read IR pin into this variable, and we have to distance will be calculated by 65 power volt minus 1.10, and this is the LCD cursor. So now we have to click on this file and click on the preferences, and we have just compiled it. So we have to run this project, run this code, and after running this code we have to copy it, copy the link of this code. Okay, it will run successfully. So we have to copy this link, and we have to use we have to provide a path for this Arduino. The path for Arduino is this one. We have to click on OK button, and now we have to run it. Okay, this is the project, and we have to use it. This is 95.03 centimeter. So this is a proximity sensor with this here. The proximity sensor pin number O, G, and V. The pin number O is connected with the inductor, and this is connected with the capacitor, and this is the voltage across IR. It will send one IR to the this Arduino. So this pin will also be we have to use this code also by we have to edit this pin by okay, we have to edit it. Okay, we have to edit. Now we can connect it. Okay, now we can connect the pin number this pin to the for our simplicity, and we have to connect this pin at pin number analog 0 pin, and we can easily connect this one with it will confuse you, therefore I will edit this code. Okay, so this is we have to connect we have to sorry, we have to connect it is connected. It is connected with the D7 of the so we have to okay, we have to disconnect this pin. It is connecting to the D7. Okay, sorry, we have to connect this D7 with the we have to connect this D6. Okay, we have to connect. Okay, sorry, we have to okay, now we have to this D6. Okay, 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 okay. D6. Now we have to connect this D5. Is this D5? This D5 we have to connect pin number 11 with the D4. Okay, we have to now arrange this because it will not very okay, we have to not okay. Now we have to now we have connected with pin number 12 with the enable pin of the LCD. Okay, 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 okay. So we are connected. Okay, now we have to connect pin number 13 with the RS pin. Okay, this is the connection. Now we have to again run it, and we have to move toward this LCD, and for this we have to again uh, run the program for it. Okay, now we have to stop it, and we have to click we have to click on the okay, we have to click on this code and click on the code, and we have to again verify it. Now we have to copy this link again, and we have to click on the project Arduino, and give the path to this Arduino, and then we have now to run this power project. Okay, so there's a, I think, connection problem. The to okay, and now we have to again run it. Okay, we have to stop it again. Now we again run it now. Now it will run it. Okay. So this is the IR sensor value 92.23. So uh, okay, this is sensor 1 value. Due to my CPU usage, it will not working. This why it will take some time to run the project. Okay. Okay. We have to uh, so uh, this is the IR sensor O pin, C pin and V pin, which is connected to inductor, capacitor, and this is the voltmeter. There is zero point 0.7 volt drop across this capacitor, and this output is connected to the IR sensor, and this will be connected to this pin. And now we have to use it, and now we have to move toward uh, uh, this potentiometer. This potentiometer is the test pin. Okay, this is the test pin, and we have to increase or decrease our value by also clicking on it. Okay, we have to use it. Okay, this value 74.92. Now we have to change it. It is 62.58. So we just click on it, and now it is 15.12 centimeter. Okay, so by varying this potentiometer value, the value of IR calculating distance will be increase or decrease. Okay, so we have to look into the uh, look into the code also. We have to look into code again. So this is our begin terminal. Okay, 65%, 65 into power of volt. Okay, uh, the float value is, if we get the voltage, this will give you the voltage value. The voltage is IR pin into 0.048125, and this one is the float distance. Okay, this is the float distance. The float distance is the from this voltage we will calculate the distance. So 65 into power of volt n minus 1.10. So here at this test pin, this test pin will show you that this test pin is used for the uh, for the obstacle between IR sensor. So when there is no obstacle, so there is zero resistance, it means there is no obstacle. So the value is 15.13. Now we have changed this value. So when the value is 0, its value is 15.2. Now we have increased this value. Okay, now we have increased this the distance between this obstacle. So its value is now 11.65. Now we are again increasing. Okay, now we have it is 12.17. When it is when it is 100%, it means the voltage is 5 volt. Okay, here the voltage is okay, it is the voltage, it is 0 voltage. On 100% the voltage is 0. So the distance is maximum. So and when the voltage increases, when there is an obstacle between them, so the voltage increases. Now the voltage increases, but and the distance is 21.50. Percent, and the value is 11.3, and the value is 11.3, and the voltage is 5. So it means there is no obstacle. It means there is no obstacle. Now we have to increase this potentiometer value. Now it is now value is okay, we have to increase it more. Okay, now it is 100%. At 100%, on 100%, okay, it is not again. We have to run it. Okay, we have to run it. Now it is on 100%, the value of voltage is 0 and the distance is infinite, because there is an obstacle. Okay, now there is an obstacle. Now we have to now we have to decrease this percentage. So the value will increase towards the 5 volt. It will increase towards the 5 volt. It means there is no obstacle. Okay, there is no obstacle. There is no obstacle, and the distance is the distance between the IR sensor and the obstacle is 0. Okay, now it is toward the now we have to I have proximity sensor. If test pin potentiometer is at 0%, at 0%, and there is at 0% when there is at 0%, here it is on now 0%. The it is on 0%. Okay, it is at 0%, 5 volt. It means there is an obstacle in front of IR sensor. 0%, and there is 5 volt, and it means there is an obstacle. There is an obstacle there is an obstacle in front of IR sensor. If test pen is at is it yes, we have to again copy it. Its test pen is at 50%, so there is 2.5 volt, and it means there is an obstacle within the range of IR sensor, within the range of IR sensor. If it is at 100%, if test pin if test pin potentiometer is at 100%, it means there is 0 volt, and it means there is no obstacle. Okay, now thank you for the today lecture, and good luck.